Hello there and welcome to Unit K. This unit is on search databases with emphasis on Elasticsearch and Kibana as our dashboarding tool for Elasticsearch. So on the agenda for this unit, what is a search database? How does it work? How is it organized? How is it different than all the other things we've been using so far in this course? What are the common use cases of a search database? Then we'll dive right into the Elasticsearch architecture, understand how data is stored in Elasticsearch, how Elasticsearch scales, and then we'll look at various ways that you can get data into Elastic. And then we'll conclude with a look at Kibana dashboards. We'll look at the different ways that you can dashboard things in Kibana. We'll look at building maps and dashboards and cards and things like that. And also we will look at how this Elasticsearch database will integrate with Spark and Drill. Okay, cool. So let's talk about search databases. Search databases are a little different than anything we've seen before, but what's interesting is that just about every database has the ability to do this thing called an inverted index. And the easiest way to think about an inverted index is it's an index over every single thing in your database. So by default, everything is indexable. So imagine we're back in the Cassandra world and you make a table and then you create an index over every single column in that table that you made. You would, in essence, be doing the exact same thing as a search database. The way the search database works is as documents are added to the database, any structure that it can imbue from the data that is put in the document gets created as an index. And so this could be as simple as the words that appear in the text of a description of the blog, or it could be as general as the looking for the field author and then indexing on the author's name. So the inverted index really will take all of the text and make it searchable. And because of this, because we do this, we don't have any concept of, foreign keys or connecting one document to another. It's like MongoDB in the fact that it has like the semi-structured data, which is usually in JSON format, but doesn't have to be. But then on the same time, at the same hand, it's like Cassandra in the fact that it can be highly indexed. And it's and generally the architecture is eventual consistency and guaranteed write is important. So why did search databases come about? Well, they generally were designed to solve a very specific problem, which is you have several documents, and those documents usually are web pages, and you want to be able to run a query that finds web pages that match a certain thing, right? You want, for instance, to locate every instance of the word IST769 across all the web pages on your institution, and then retrieve them. And what you don't want to do is have to crawl every web page to do that. So what you do is you have a crawler that visits the page and grabs the page content. Then that would put the page in Elasticsearch or some search database like Lucene, and then that database would create an inverted index. Then you would go to the dashboard of that particular search database, whether it's Lucene or Elasticsearch. In this case, it would be Kibana. And then from there, you can type in some search queries and find the web pages that match the search query that you're looking for. So these databases are not general purpose. They have a special purpose, and that is to optimize read. And generally what you're doing is you're creating and reading. If you put the same document up there, it will update the document that's there. But this is not the kind of database where you're going to like manage customer data in it. It's not that kind of database at all. As a matter of fact, search databases are generally used along with other databases. So you might take your data out of MongoDB and ship it to Elasticsearch so that it's easier to ad hoc query the data that was in MongoDB. Or you might take relational data and ship it to Elasticsearch so that it's easy to find specific items or records in that relational data. As a matter of fact, most of the database management systems have what's called a text search facility in them, which creates an inverted index over any of the varchar fields so that you can search for a word like fudge, and it will show you all of the rows and columns that have fudge in it. So this is not something that is unknown or foreign. It's just the idea of making a separate database out of it is where the real innovation happened. Most of these databases are base and not ACID, so they're designed for eventual consistency, and they support high degrees of failure yet still hold on to the data. And one thing you're not going to do is get consistency, but that's not really what you're looking for out of inverted index. One thing you'll notice when you use Elasticsearch in this course is you'll add things to the index, and then if you try to query them too quickly, they're just not there yet, because it takes a while for the inverted index to build and update, and so there is a degree of you gotta wait before you actually see. So this even more so than Cassandra. This is true base, where you insert it and then you go and ask for it immediately and it's just not there yet, and then you ask for it again a minute later and it's there. So this is a great example of true eventual consistency. It will be there, it's just not there immediately. Again, the claim to fame with a search database: laser fast search. Okay, you can search by anything, so any piece of text that's in there you can search by that text. It is not used, like I said, as a general purpose database. It's normally used as what's called a data sink. The data is shipped to Elastic and then sits there at rest. So as part of a data pipeline, you might have a job that pulls the data out of wherever it is and then dumps it into Elasticsearch, where that will make it easy to search over the data. You can go in and delete documents out of Elasticsearch and things like that. It's just, again, it's not generally categorized as a typical CRUD database where you're gonna you're not going to manage a shopping cart with it. You're not going to even manage a product catalog with it. But what you would do is you would take that product catalog and have some of it in MongoDB and some of it in Elastic, so that on your website you could provide a facility by which someone can search conveniently for products. That's where search databases make sense. They complement other databases. So again, any situation where you need to search over text, this is a use case for a search database. So if you want to build your own search engine, this is a good use case for it. Log analytics. Take all your logs from all your applications, send them to Elastic, categorize where they came from by source, then provide a text box where you can search for a certain error condition, or search for just the word error. Maybe you just search for the word error and you say, oh, look, no errors at all. Awesome. So it's really great. One of the hard things to do with logs is find an event in a log, right? So, you're running a system and people are logging in all the time and doing all sorts of activity in there. And then all of a sudden you're like, I need to find out if this event happened and when it happened. Searching over log analytics is a really great way to answer that question. Otherwise, you've got these massive piles of text files that you have to somehow sift over, and it's just not good. You can also use it to find out what people are doing. So if you want to measure, if you want to like sort of explore maybe social media marketing, you can take maybe touch points on the web and then what people are saying in social, and then put an inverted index on there, and then search for a keyword like new sneakers, the new name of a sneaker, and it'll come back with the tweets that match that, and then also in that same index, it might come back with web pages where they went and looked at the sneaker, or maybe if you're looking for customers that might blog about it or something. So you can do really interesting things like that. And it also does a really great job with metrics and operations. So you can take operational data like telemetry, what's going on with your systems and services. You take measurements of that, you ship them to Elastic, and then you can sort or search those. And generally, these are usually over short windows. You don't care about what happened like a month ago. That's irrelevant, but this might be like over a 24-hour window. So this is like for operational assistance. So if someone who's in charge of all the servers needs to identify a server that's misbehaving, right, they can easily use the search facility to build dashboards that will help them determine what's going on. And it would be a situation where maybe you're just looking at the dashboards a lot as part of your job, or you can actually maybe set up alerting. There's lots of ways you can go about doing it. Okay, let's talk specifically about Elasticsearch and the Elastic Stack. So Elasticsearch is a search engine based on Apache Lucene, which is an open source Java-based implementation of a search engine. Elasticsearch scales horizontally through data shards across nodes, like the way Cassandra does it and the way MongoDB does it. It consists of inverted indexes. So think of like a MongoDB collection, but everything that's in the collection is a searchable term. So that's the beauty of an inverted index. It does not discriminate as to what is indexed. All of it is indexed. And so therefore, you have unlimited power to search by any little thing that you want to search for. If you want to find out if the word or appears, you can search for or. Doesn't matter. You can also search for patterns. Like maybe you want to see Michael A. Fudge in there. You can search for exact patterns like that. Okay, so again, with an inverted index, every unique word appearing in a document within the collection ends up being a key in that index, right? And then that index would refer back to those words. And then there's a REST API that you can use for adding, removing, updating documents, and querying them. So what you get from base Elasticsearch is this database where if you want to add data to it, you just use a REST endpoint. So this makes it very programmer friendly. It's super easy to, every time you write to a log file, to take that same thing you write to a log file and ship it to Elasticsearch. Or even better would be to not program that at all and just have a program that runs that looks for the log file, and then it notices something changed in the log file. So the application does what it normally does. It logs the way it normally logs. And then you have an integration that just reads that log file as input and keeps putting it into Elasticsearch. And it might upload the same file 6 or 7 times, replacing it every time in Elasticsearch, and that's fine. That's totally fine. And then that's how we detect, changes to that data over time. You can do a lot of this stuff in HDFS and the Hadoop world, but what you don't get is that inverted index. So you're going to get near real-time query capability. And I say near real-time because it's eventual consistency, right? So there is going to be some delay while the index is being built. And while that index is being built, you are not going to be able to query the data you just added. Okay? But for most purposes, this is good enough. And if you need to shorten that real-time capability, you can by scaling out Elasticsearch, if you scale it out. So you've probably heard this term before, the ELK stack, and this are the platforms that sort of work with Elastic. So we have data ingestion. This is how we put things into Elastic without doing it manually. One of the ways you can get things into Elastic is by using Logstash. Logstash, basically what it does is it looks at a file, and then it detects a change in the file. And then when the file changes, it takes the data from the file or the entire file, however you choose, and puts it in Elastic. So this eliminates the need for you to have to, every day, click a button to load log files into Elastic. You have some app that's running that lets people log into, like Blackboard, for example, and that generates logs, and then you have Logstash monitor those logs, and then based on changes to those logs, it takes the changes and puts them in Elastic. Or it can take the file that's generated and put that into Elastic and keep overwriting the file, and then when the log rotates, it puts the next file in. There's lots of ways you can set it up. So that's Logstash. The Logstash is like bulk ingestion. So you're not going to do Logstash on a row-by-row basis. Logstash is, every hour we're going to start chunking up more logs into Elastic. If you want more real-time metrics, you got to use Beats. So what Beats does is it integrates deeply with the application. And so what it does is it would look at every line maybe that was written to that log. And then as the lines are written to the log, line by line, they are shipped to Elastic. And so this gets you a more granular exchange of data between your application and Elastic. And because it's smaller data, it can be updated more frequently and not have to incur so much of a delay while the index is being rebuilt, and therefore gives you more close to real time, as opposed to the batch where you might, upload 4 million rows and then you have to wait for the index to rebuild. Beats is uploading a row at a time, a row from the log at a time, which means the index doesn't have to get rebuilt. It doesn't take as long to rebuild the index. So then there's Elasticsearch itself, which is the database. And, so this, by the way, in the ELK stack, this is the L, Logstash. Sometimes they call it the EBK stack for Beats instead of Logstash. But Logstash beats ingestion. That's the L part of the ELK stack. L, or E, is for Elasticsearch. And again, that's our database. And all Elasticsearch knows is an HTTP REST endpoint. So Logstash and Beats are integrating with that REST endpoint where we are sending data to the database. And again, you want better performance, you make a cluster. Right? In this class, we just have a single node, and that's kind of why our performance isn't that good. But if we had several nodes in a cluster and we're distributing that data and sharding that data over the cluster, things are going to work a lot better. And then you need to have a UI where you can sit at a text box and type queries in so that you don't have to know how to do that with a REST endpoint. And that's what Kibana does. It also gives you the ability to build and design widgets. And those widgets give you things like drop downs and checkboxes, and you can make tables of data. You can display a map. You can display like cards, like scorecards that say 57 people ordered today. You can just display numbers or metrics. And this will allow you to build out a visual interface of your search data. basically. That's the idea behind Kibana. So there is something called the Elasticsearch open source, and this is under the Apache open source license. And then there's something called the Elastic XPack, which is under the Elastic license. And these things under the XPack are not free. You need to pay for them, and the things under the Elastic Stack are free. So this is important to know what parts are free, what parts are not. Just like we saw with Neo4j, not all of it is free. So in the Elastic Stack, we have Kibana, Elasticsearch, Logstash, and Beats. Okay, and with this, you get a very simple security model where you can sort of set up, lock down that HTTP REST endpoint, and then maybe put it over SSL, and that's about as good as you get. If you need more than that, then you're going to need the XPack because it gives you like more role-based access security. You get monitoring. You get the ability to do alerts. So like I said before, maybe you want to set this up so anytime you get an error, it sends a text message. Like you have all these logs shipping to Elastic, and then Elastic is looking for error. And then as soon as it finds error, it sends a text message. And then if it finds that same error again, it won't send you a text message, but you can do, another query, and then that query might say, well, I found another error message, and then it'll send that one out. So you can do alerts like that. There's also some graph features that you can get access to in the XPack. And there's some nice reporting features. So like building reports. Okay, let's talk about the open source components in a little more detail. So we have Logstash, which is a data processing pipeline. We can ingest data from a variety of sources. You can apply transformations before storing in Elastic. So a great example of that is you have a log file that has an IP address in it, and you use a GeoIP tool to take that IP address and translate it into a place on the globe. Maybe a Latin long and a street address in a country and things like that. And this enriches our data so that you can maybe build a map that says, oh, look at all the people that are coming from, Kentucky and visiting my website. And you'll be able to do something like that pretty simply in Elastic if you GeoIP your data with Logstash before dropping it into Elastic. You can also parse dates. So another thing you can do is like you have a date in every log, and you can say, well, that's a Tuesday. That's in January. That's in the year 2020. And then when you do that, you'll have all these additional things you can search by. So then you can do stuff like find all the people from Kentucky that visited on a Tuesday, right? All these things that we would normally do as part of regular retrospective analytics that normally would be done relationally in a data warehouse where you have to build a star schema. If you can inject those lookups before you write to Elastic, because Elastic doesn't have a join, right? So you're gonna have to write exactly the story you want, right? You'll be able to do those kinds of analytics pretty easily. So some of these are built in, like, they're just built in and you can use them. And then others, you can just write your own transformations, and you can write them in any language that you want, Python or Java, etc. And then here's the docs on Logstash. All right, let's talk Beats. Beats is a data shipper. It's just a newer version of what Logstash is doing. And the way it works is that Beats has a resident program running that functions as an agent, and that agent needs to be able to see your log stream. Whether your log stream goes to the console or it goes to a file, it doesn't matter. It needs to be able to sort of pick up on that. And then from there, you can then do some basic transformations, process it, and then ship it to Elastic. And there's different kinds of beats. Like there's a file beat, which looks at a file, and then when it notices a change in the file, it will scan that file and then ship the changes over to Elastic. Okay. That's useful for logs. You can also have a heartbeat, and a heartbeat does exactly what you think. It just checks to see if something is still running. Like you can heartbeat a application and say, on this computer, is this application running? Yes. Okay, good. On this computer, is this application still running? Yes, that's still good. On this computer, is this application running? No. Okay, it's not. So the heartbeat will do that. There's a packet beat, which is kind of cool. What this does is it inspects what's going on over the network. So this will allow you to do some inspection of the kinds of traffic happening on your network. And there's a metric beat, which we use that to get things like how much CPU is being used, how much RAM is being used, what's the disk IO. It'll get you like basic hardware and application metrics. There's the URL if you want to learn more about the different beats. We won't set up a log stash or a beat in here. It's sort of beyond the scope of what we can really cover in this course. It doesn't require some programming that I don't know if many of you have or not, and it does require, if not that, some scripting and some really good understanding of the file system, which I don't know if you'll have or not. So, it's not a good idea to really sort of dive too deep into these. Just know that they're available and know that they can be configured to ship data to Elastic. And this is mainly the way how things get into Elastic, is in an automated approach. Okay, then there's Kibana. So Kibana is like the front end for Elastic. It allows us to search, observe, manage, monitor data in Elasticsearch. There's a box where you can just type in any query you want and get results back within Elastic. But you can also build analytic dashboards. You can build maps. You can build something called a canvas. A canvas is like a pixel-perfect image that is updatable. So imagine you have a TV set, and on that TV set, you want to do some live stats for like March Madness or something like that. You could set something like that up with a Kibana canvas, because when you show the canvas, you would say it's 1080p, which is exactly the size of the monitor. So when you show the canvas on the TV set, it would take up 100% of the TV set. You wouldn't see any other UI stuff other than what you built in the canvas, and the canvas would update itself as the data updated. So that's what's kind of neat about these canvases, is it might say, currently number of games being played, 14. And then, now there's a new game that started. Now it says 15. Now 2 games ended. Now it goes back down to 13. It just does that automatically. And what you're doing is you're tying each of the elements in the canvas to a data feed. You can make the canvases interactive, but usually you don't. Usually that's kind of the idea behind a dashboard. So what's interesting is there's a couple ways you can query Elastic. There's the Lucene query language, which is the default in Elasticsearch, and then there's an improved query language that Kibana offers called the KQL, and there's also a variant of SQL that Kibana will let you query with as well, and you'll see all of these as we go and do the demos of Elastic. And here's a link that explains more about Kibana. Okay, let's do a demo and explore what is going on here with the Elastic Stack. I just want to show you where the bits and pieces are, how do you get to each of those bits and pieces, and where the important parts are, because there's a lot of things in the Kibana UI that are really irrelevant to what we'll do in this course, because it's got a lot of features, and you could probably spend half of a 3-credit course just on building data pipelines with search and this particular product. But again, I don't think that's a wise emphasis of our time. Products come and go, concepts don't. What's important is understanding the concepts, using them in practice to sort of reinforce them. That's what we're all about. We're not about training you for Elasticsearch and Kibana as much as we are having you understand how these concepts all kind of come together. Okay, here I am out in the Elasticsearch portal. That is it's actually the Elastic portal, and it's set up through Kibana. This is actually the port for Kibana right here. And I just want to show you a couple things. So, and I'll come back to this a bit, but there's this add your data. And then it shows you all the different ways that you can get data into Elasticsearch. And it will read a lot of different tools. Now, the thing to understand is you can really have it read anything that's a log. I mean, it's just search data. These are just ways to help you integrate easier, because they realize that it's hard to integrate. So they offer all these little things that will help you integrate. Like if I go down here to, Kafka logs, it gives me instructions on how to do that. All right. And so that's useful, because if you have Kafka and you want to integrate it so that, a Kafka topic drops into Elasticsearch, this is how you do it. And it's just using a file beat. So, I could, if I knew what I was doing, I could just use a file beat and configure it myself. But that's usually not something that is easily configurable by someone. So another example of this, let's see if there's one for a database that I can find in here. See if I can find one. So here's one for Microsoft SQL Server, but this is metrics. So this is getting you like what the computer is doing that's running Microsoft SQL Server. But here's one for logs, right? So I can use this to get the log file for Microsoft SQL Server. And you can see that this is, again, a file beat. It's a file beat that we would use. So it sets up very similar to the Kafka example. You can always upload a file here. So you could take some JSON file that you have and just upload it to Elastic and then start searching it. This is kind of cool, and I at times I will do this, like if I have a CSV file and I'm just trying to explore it. This is a great way to do it, because it adds enough structure to it where you can just say, this particular column is at this. Like if I upload a bunch of students in here, I can say, well, give me all the freshmen. Or, give me all the freshmen in this particular course. I could do that pretty easily with this inverted index. Now, can I find all the freshmen with a GPA bigger than whatever? Yeah, maybe not. It depends on a couple of things, but these things are possible. So let me show you what's important to know in this Elastic UI. So over here, you're going to see this analytics dashboard. We will mostly spend our time. A good place to start is in Discover. That's going to take you to this page here where you can just search by things. You'll see that I have an index here called people that I've already set up, and I'm going to set this index up in a bit in the next demo, but I want to have something here to show you. So this index was set up, people, and I can go up here and just find something like name. Let's see what's in this index. I got name and then major, so I can do like major math. That. And see, look at that. It gives me all the documents that have a math major in there. Wait, or maybe I can do Dean's List. True. Okay, these two people are on the Dean's List. I can do false. And now I get the ones that aren't, right? I can also do ands and ors and stuff like that, right? I can do this again. Let me do this. GPA is a 3.2. Okay. So there's lots of different things that you can do here. And, again, this is just the tip of the iceberg, but this is where you want to go when you want to visualize the data in your database. There's the Discover, which I'm on. You can also build a dashboard here. You can create a map here, and you can create a canvas here. And we'll do all of these. We'll do all of these. There's also some ML, but this you have to pay for. So again, this is, like it's all here, but then it's going to ask you to, up your license and pay for it. And we're not going to do that here. Okay. So now you might be wondering, like, how do you manage the index patterns in Kibana? So what you want to do here is if you go to the hamburger menu and then go down to the bottom, all these things here, we just don't have the license for these. So they're just not relevant. But if you go down here to management and then go to stack management at the bottom, stack management, you'll see that there is a Kibana section and then a data section. The data section is Elastic. So if I go to index management under Elastic, I'll see a bunch of Elastic indexes that I have in here. Okay, these are ones that I've already made. When I start the demo in the next part, it'll be empty. That's fine. So that's good. That's great. But if I want to be able to query these outside of Elastic, and I want to query them in Kibana, I got to create what's called an index pattern. And an index pattern is just a way to import the Elastic index and then add some metadata to it so that it becomes a little more comfortable to search. We can also apply some really simple and basic transformations on there to sort of improve the look and feel of the data that was created with the inverted index. So this is what all the fields look like, and I can add a custom field, things like that. But this is all part of Kibana. And then the actual data in Elastic is found here under index management. So those are the two things that you want to know something about in order to be productive in Elasticsearch and Kibana. All right, let's talk about the data model that Elasticsearch uses in its architecture. So here's the basic architecture. You're going to have one or more nodes, and each of those nodes is going to be in the cluster, and the documents are stored in an index, and the indexes can be divided into types. So you can have one index called people, and it can have a type called college professors and another type called students. Generally, every index has a default type that's required called _doc. Okay, that's like the default type on the index. But you can have more than one type if you want. Okay, and the idea is that the different types are stored in the same index. So there might be good need to store the same types in the same index. All right. Indexes are sharded by a key. The key can be created by hash. It could be identified when you add the document. It can be auto-generated. Okay, and so just the same way that the key gets sharded in Mongo, it happens here in Elastic as well. And so some of these customers, this says index orders and this says customer. So some of these customers end up on node 1, some end up on node 2, some end up on node 3. Some of these orders end up on node 1, some on node 2, some on node 3. That spreads things out. And then you can configure the index so that the shards are replicated. And you can say, it gets 2 replicas or 4 replicas or no replicas, right? You can set it up any way you want for that fault tolerance. All right, the data model. Indexes, what do they look like? Indexes can contain documents of any format. Documents are similar to MongoDB documents. Think of that metaphor works. The indexes themselves are like collections, and the fields and attributes that are discovered automatically within the contents of the document that create the inverted index are just like the fields and attributes that you would see in MongoDB, except all of them are indexed. That's really fundamentally the difference. All of them are already indexed. This greatly speeds up the read operation at the expense of the write. If your document's in JSON format, it will automatically be detected in JSON format and be structured accordingly. So you'll get fields and things like that, which is really nice. If it's just an HTML doc, it'll just be free text search. Indexes can be searched using what's called the Lucene search index or search syntax, which is specified in this link here, and that's just a common way. It's a domain-specific language for searching with Lucene, and Elasticsearch supports it. So how do you get data into Elastic? How do you get data out? You're going to use one of these HTTP verbs like get or read it, create makes it, put updates it, and delete removes it. And then you will hit an endpoint depending on what you're doing. If you want to update, if you want to create a bunch of them, like you have 5 customers that you're uploading all at once, you have to hit the bulk endpoint. So you'd say, you know, my Elasticsearch server / bulk, and then you can give it a payload of more than one doc. If you hit the search endpoint, then that means you're asking for the data back out. And so you should always use a get with the search endpoint. And then if you get mapping, what you'll do is you'll get which fields are inferred from the data that you uploaded. Again, if you upload a JSON document, it will try to guess the data types and guess the fields in the JSON document. And that information is stored in the mapping. One thing you can do is you can post your mapping before you post the JSON document. So that way it doesn't guess how you want it to read the JSON document. You can tell it exactly how you want to read that JSON document. We won't do that in this class. We'll always just infer the JSON document. Okay, we're going to get down and dirty and do a demo here. And what we're going to do is we will create this people index. And then we will have a default in there of doc in that people index. And that doc will be our default index type. And we will use curl, which is a command that you can use to send HTTP requests from the command line. We'll use that curl command to send data to Elastic. So this -d is the data that we will send to Elastic. And then we will get a number of documents that are in the index by hitting the count endpoint. And then we will do some basic searches using the Lucene syntax. And I'll talk about the Lucene syntax with you. And we'll do all of this from the terminal window here. Do it all from this terminal window here. And just use curl like that. And, you know, it's very low level, but it gets the point across about how Elastic works. And then I'll show you in Kibana what's happening when I execute these commands from the command line. And that'll be basically what we'll do in the demo. Okay, let's give it a shot. Okay, I'm out here in Jupyter Lab, and I've decided to not use the PowerShell interface because the version of curl in PowerShell here doesn't seem to want to cooperate. And I know how to use curl. It's just like in PowerShell, you can't use like these quotes or this dash or something. I don't know, something weird. So I'm not going to bother with that. I'm going to use the terminal in here. I'm going to go File, New, Terminal. This is going to give me access to a Linux command line where I know that this will work. So I'm going to copy one of these to start and then explain, and then hopefully it works, and then I'm going to explain it. Okay, so that worked. So what are you looking at here? Let me just try to break this down into a more manageable setup. Let me do this. Let me break this down a little cleaner here. So this part here, I guess I could just read it to you. This is the endpoint, and it's not localhost, it's Elasticsearch because I'm inside of Jupyter Hub. And then it's going to be people, and then people is my index, and then that is my my name inside the index. And then I'm going to send it some JSON. This is the header. And then the data I'm going to send it is name Mike, major math, GPA 3.4. And it said it worked. So let's do this. Let's go over here and let's go down to stack management and let's go to index management and let's find that people. And then under people, there is, I'm going to zoom it out a bit. There is, what do we got here? We got GPA. We got major. We got name, right? And those were inferred. Those were guessed from the data that I sent it. And then if I go here to stats, you'll see that the number of shards, okay, and you'll see the docs that we have going on here, and what else do we got here? There's one value in the index. Okay, let's get a count of that. So let's do this now. Let's go back to that command line. Let's prove that there's one in there. So I'm going to do this. Let me zoom this in again. And I'm going to do this. I'm going to say curl. And I'm going to do a get command to my Elasticsearch server. And what I want to do is I want to issue a cat command, and I want to get a count of students, or a count of people. Or no, I said students, right? It's people, students. So let's get a count of students. I think this is the way to do it. Let's see what that gets us. Oh, I spelled Elasticsearch wrong. That does not help. That looks better. Okay. And it says no resource type students. So let's try people then. I might need people and students. Okay, there's one person in there. One. See that? Timestamp, date stamp, timestamp. There's one. Let's add another one. So let's go and hit up arrow till I get to here. And now what I'm going to do is I'm going to take this out. I'm going to put in, let's put this on the next line so that it's easier to see. And let's copy this. I'm going to go here and let's copy this one. This one is name Phil major math 3.2. Copy. And then we're going to say -D name Phil major math GPA 3.2. Oh, I got some mistake in here. I got to make sure I'm on the right endpoint. Let's try that. That looks better. Okay, now that worked. Okay, so that got added. And then let's get a count again. And now there's 2 in there. Let's try to add the same thing again and see what happens. And what's the count now? 3. So again, it will add the same thing again because we didn't specify what the ID of this is, right? And if you go back to Elastic and look at these mappings, right, I'm not specifying any ID in here. It's just generating the IDs as I go. All right, let's there's 3 docs in here. Let's put one more doc in there. Let's go back here, hit the up arrow, and we're going to put in, let's go look at the last one here. Pete Bio 37. Pete Bio 37. 3.7 bio, and then let's put in Pete. And while I'm at it, let's just put one more in here. Let's do Mary. And let's leave her major out of it. Let's say Mary. And then she's not going to have a major, but her GPA is going to be 4.0. Oops, I got a mistake in there. Mary. Take out the major. Nobody really likes to use Elastic this way, but this is the API for it. Okay, now that's in there. Get a count again. There's 5 in there. Now, here's the thing, is like, this is not really the way that people want to use Elastic. You want to go in the way I showed you before and import that data, right? You want to go here, right? Add your data, use one of these integrators, right? Or upload a file. That's the way you want to do it. You don't want to sit here and use the API, but if you understand how it works at a very low level, that's never a bad thing. Never, ever a bad thing. All right, let's get back to the example. So now I have some docs in here. Let's query the docs. So I can say curl. Let's clear out. Let's go back. Okay. Curl. Let's do a get. And let's get localhost. Oh, it's going to be Elasticsearch, right? 9200. And we're going to search through people. And we're going to search for major math. Oh, this is a query, so I got to say query equals major math. Okay. Whoops. I got a mistake in here somewhere. I got to put a slash here, like that. Got to hit the right endpoint. Okay, and there you go. You got, this gives you back all that. It's hard to read, right? Let's be honest. It's hard to read, right? This is how you make it easier to read. Major math and pretty. Okay, now it's easier to read. So I got 3 hits using equals. And then here are my hits. Like math, there's the ID. Right? Fill math, there's the ID. And another fill math, there's the ID. If I wanted to, I could have specified this ID. And that's probably not a bad idea to make sure that you don't add the same data in there more than once. It works a lot like MongoDB in that regard, right? This ID is the document ID. Although we won't really be using Elastic this way, so I don't want to spend a lot of time on that. Let's go ahead and do a different query now. So let's get all the bio majors. So I can go in here, major bio. And then there's Pete with that bio major, right? I can also do this if I want to get people that have a GPA between 1 and 3.5. I can do this. Search pretty and query the GPA is between 1 to 3.5, like that. Now you're looking at this going, I'm never going to remember this crazy query language. It looks like I'm not doing a very good job of doing the query language either. Man, I'm just horrible at this. I will get it. It's supposed to be Q equals GPA. Oh, now what am I doing wrong? Let me see. People search pretty and Q colon GPA. All right, I finally got it to work. It's because of the way that curl works. It doesn't like this square bracket. What I wanted to say is this. I'm going to just show you what I meant to say. I meant to say this. GPA 1 to 3.4, like that. But a couple things are wrong with this. One is these square brackets. Curl doesn't like them. Two, these spaces. Curl doesn't like them. So you have to do what's called URL encode the URL before you send it. It's a pain in the neck. Anyway, it looks like this when it works right. It looks like that. I am encoding these spaces as %20 and then using this -G to handle the brackets. And I get this. And so the output now is only GPAs less than 3.4 or bigger than 1. And that shows up. So I know that was long and hard, but that's sort of how this stuff goes when you're using the command line to do it. Moral of the story is you can do it. That's the moral story. So we saw Elasticsearch search, but now let's talk about Kibana search. So Kibana can't search without an index pattern. An index pattern covers one or more indexes, and the index pattern fields are created automatically from the Elasticsearch mapping fields. In addition, once that's done, you can customize the fields in Kibana relatively easily compared to the way you would have to do the customizations in Elasticsearch, which is as you saw from the command line. Each text field that you see in Kibana has a .keyword version, and that .keyword version can be aggregated. So if you want to count the number of times Mike Fudge appears in the documents, you can do that. Thank you, keyword field. And again, as I said, custom fields can be added, and adding these custom fields is easy. It's much easier than trying to do the same thing in Elasticsearch, and so it becomes a great way to build derive columns from your data. And another nice thing about these index patterns is as you add more data, the index patterns will apply any derived fields. And maybe I can demonstrate that if I have time. So what I'll do now is we'll create an index pattern from our people students there, and we'll make a derived field for Dean's List. And then we'll go and search in Kibana Discover, and if I've got some time, I'll go back to that command line and add one or two more documents, just to show you that the derived fields in the Kibana index pattern happen automatically. Okay, let's try it out. Alrighty, I'm out here in the Kibana UI, and I'm looking at the Elasticsearch indexes here, and here's my people index, and there's 5 docs in there. And what I'd like to do now is create an index pattern in Kibana. What I want to show you here is I don't have an index pattern right now If I go here to index patterns, I don't. I only have one for customers. So I'm going to go up to discover, and I'm going to try to search for some people. And you're going to see that I only have customers. That's it. I don't have people in here. So I need to create an index pattern on my Elasticsearch index in Kibana so that I can use Kibana to search it. Okay, and you might say, well, isn't that counterintuitive? Yes, but this is where Kibana excels, is that you can enrich the data that is in your raw Elastic. So having this additional layer is important. All right, so let's go back here to stack management, and let's go back to index patterns. And now let's create an index pattern, and it'll ask you which of your sources in Kibana you want to use. I'm going to use this people one. Okay, and then there's my source. Using a wildcard is important because you could have several indexes in there. Like this is where Kibana is really nice, is I can have students, faculty, staff. If I had some way to wildcard all those into a single Kibana search pattern, I can search all of them. So, thinking about ways that you're going to put things into Elastic is important, because if you wildcard them correctly, you should be able to yank them back out across multiple, one Kibana index pattern, but multiple Elasticsearch indexes. All right, and let's go ahead and is there an ID? I don't have an ID, so in this case, I'm just going to create index. And it automatically infers from looking at what was already configured in Elastic. It goes ahead and guesses the fields. And now I can add my own custom fields if I want. So I'm going to add a few custom fields here. I'm going to add one field. I'm going to call this Dean's List. It's going to be a Boolean. And then we're going to set the value of the Dean's List to be emit. Gives you some sample data over here. See that? Gives you some sample data over here. And you can kind of go through the items to figure out if it's going to work. So we're going to emit the doc GPA column, right? That attribute. Is that bigger than or equal to 3.4, right? And that's going to be the Dean's List, but I need to actually get the value out of that, right? So like Dean's List is false, Dean's List is false, false, true, 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 false, false, okay? Okay, I'm going to add another one just for fun. Let's call this one academic warning. And we're going to make this a Boolean as well. Anybody less than 2.0, value less than 2.0. That's going to be academic warning. Looks good. So now I've got a couple of derived fields in there. Now, let's go back and add some more people to the Elasticsearch index to show you that the Kibana index picks them up automatically. The Kibana index pattern picks them up automatically. Let's go do that. So I'm going to torture myself back over here. And here's a student, Terry, a chemistry major, 3.1 GPA. And let's add another student, Sue. Sue's major is going to be math, and Sue's GPA is going to be a 1.4. Let's add one more person, Zach. And Zach's major is going to be bio. And Zach, unfortunately, has a 1.7. Okay, I added 3 new people. Now, I didn't touch Kibana or anything like that. If I go back here, hopefully I waited long enough for things to update. If I go over to Analytics and Discover, and then pick my people index pattern, let's see if I can find some students. Let's find some students on, let's do it by major first. Find the math majors. There's the math majors. Let's find the students on academic warning. Remember, this is my derived column. Remember, before I didn't have anybody on academic warning, but now I've got 2 students on academic warning. I've got Sue and Zach, right? So that's pretty cool how that automatically refreshes that Kibana index pattern for me based on those Elasticsearch indexes, and then automatically derives those columns for me. Let's try something else. Let's try major keyword. I don't know what I'm doing here, but let's try math. There you go. Pretty cool. So you can search with the Kibana query language, or you can turn this off and search with Lucene. So let me show you what I was trying to do before with Lucene. I'm going to turn that off. Now we're in Lucene world. I can do GPA. Let's do GPA between 0 and 2. There's my 2 people with GPAs between 0 and 2. I can do that, and I think I can do this, and is it and? Academic warning. I think that works. Yeah, that works. Doesn't change anything, but like I can do GPA between 1 and 3.4 and academic warning true. And I get the same results, right? If I do false here, and academic warning is false, you know, I get these guys here, right? 3.1, 3.2, 3.4. So that gives you a really good idea sort of how this comes together so that you can start to build a dashboard and start to build some really interesting analytics around your data, or at least, at the very least, search your data. Imagine these are logs that come in every, several hundred a second, and you just want to find people that logged in or something. You could do something like, I'm checking for the username. When did Bob log in? I could do name, Mike, and find out when Mike logged in, right? And there it is right there. And I could look at this and see whatever, right? So there's a lot of really great use cases for just raw search like this, let alone being able to do very interesting and unique kinds of searches that might be based on a dashboard. Now, I do want to also reiterate that normally we're going to have a lot of fields. Like 9 fields is not a lot of fields here, and that's why this search field names is here, because usually this like one row is like very long, has a lot of fields in there. So this is not common to just have 8 or 9 fields in here. All right, let's talk data ingestion options. You can load data sets through the Kibana interface. You can use the REST API. You can use any SDK that integrates with Elastic. So you can be coding in Python and have Python talk to Elastic. The difference between an API and an SDK is an API is usually accessed over the web or over the network. An SDK is like code that you use in your own code to integrate with another service. You can also use Logstash or Beats. So there's lots of ways to get data into Kibana. Lots of ways. Let's do an example where we upload some data. Let's do an example where we upload some data. We're going to upload some customers' data, and then we'll create an index pattern on that customer's data. And then we will also show an example where we load in some tweets via the API from a Python script. So this will give you a really clear example of the many ways that you can integrate your application with Elasticsearch/Kibana. All right, I'm back out here in Elasticsearch and looking at the Kibana UI. And what I'm going to do is let's upload some data. So what data are we going to upload? I'm going to go here to Jupyter Lab and let's go look at it for a data set here. There's a data set here, customers. We've seen this before. It's got like a last name and a first name and an email and all this other stuff. I want to load this into Elastic and then set up a index pattern in Kibana. So if it's just one file, the easiest way to get it up there is probably to just go here, go to the home page, and add your data, and then go here to upload file, and then browse for it or drag it, right? So if I go find it here, and I'm going to go find it. All right, I'm in the datasets folder on my PC, and then it's customers, and then it's right here, customers. So take that, drag it, and drop it. And it figures out sort of how it's delimited and what the fields are and stuff like that. Pretty handy. And then it comes up with a default pattern, if you will. What the fields are going to be. It's actually pretty smart about this, I got to say. And then there's a button somewhere right here, import. And then while you're at it, you can also create an index pattern, right? So I'm going to make a customers index, and then I'm also going to create the index pattern at the same time. So I get a 2-for-1, and it loads it, and I'm done. And then I hit back. I just hit cancel, I guess. Is it done? I don't know. Let's find out. That was weird. So let's go to stack management and let's look over our index pattern. And there's a customer's index pattern. And if I go here to index management, there's an index there. And there's 30 docs in the index. And now I should be able to chew on that index in Elastic, right? If I go back to Discover and I pick that customer's pattern, I can look through the fields. It's still kind of loading, I think, but let's find out, right? Let's see what's in here. Was there a first? Let's see what we got here. All right, let's try gender M. There we go. Or we could do city, Syracuse. There you go. Now, obviously, the kinds of data you're going to put in Elasticsearch are not going to be this kind of data. You're not going to put reference-oriented data. You're going to put some kind of process-oriented data in your Elasticsearch, your Elasticsearch index and your Kibana index patterns. You're not going to use these categories like this. And you might put products in there or something so you can search through a product. And I guess you might put customer in there if you want to like dig out information about your customers. I guess you could. I mean, it has a wide variety of purposes. I guess anything you're trying to search over makes perfect sense to use. So who am I? Who am I to say what to use and when? Okay. So let's continue with this example. Let's show an example of getting data in here via API. Let's switch back over here to Jupyter Lab. I still got this customer CSV open. And now what I'm going to do is in here you see there's a section in this week's doc, JSearch, that walks you through simulating Elasticsearch posts. So basically what we're going to do here is we're going to loop for as many tweets as you want. We're going to generate a random, we're going to sleep for a certain number of seconds, between 1 and 15 seconds. We're going to generate a random tweet. Then we're going to create an endpoint. And see, in this case, we're going to actually use the tweet ID to uniquely identify each tweet so that we don't put the same tweet in there twice. And then we are going to post to that endpoint and throw an error if something doesn't work, and then we'll print out what happened. So I'm going to run this, and I got to probably do an install of some stuff here. Oh, I got to run this up here. Yeah, I got to get my Elastic host and port going. Even though I'm not going to use the Spark context, I am going to use the way to get, this is just regular using the requests module to send things to Elastic. So you're going to see that it's going to start streaming things to Elastic. There we go, right? So it just sent a tweet to Elastic. Then it sent another tweet, and it's using ID. And that's the ID. That's the doc. That's the ID. What comes after doc is the ID. And so this ID and that ID match. It's sending more tweets. Some of them have hashtags. Some of them do not. Kind of cool. I'm going to let this go. While that's marinating on the back burner, I'm going to go back to Elastic. And let's see what we got here under Stack Management. If I go to Index Management, there's my tweets. There's 7 in there. Right there. Reload. Now there's still 7 in there. Okay. Now let's make a index pattern for this. So I'm going to create an index pattern. Let's call it tweets. I think I'll use a wildcard in case I come up with other sources of tweets. Maybe they're customer tweets. Maybe they're, employee tweets. You can specify a timestamp field, and it'll read from the index that you chose which field possibly matches that. And in this case, it's date. So let me show you what happens there, right? There's a field date. Gives you when the tweet occurred. And this is a way to sort of add some time orientation to your data. Okay. Let's create that index pattern. All right, there we go. Got my columns in there. I got some sentiment, some mentions, and some text. So let's it says there's 25 fields in here. Let's go back up to Discover. And let's try to look at these tweets. And let's see what we can do here. Let's change my Lucene back to KQL. And let's do, I don't know, let's do sentiment. Sentiment positive. How about negative? Not getting any matches, so maybe I should try something a little easier. Like text. I'm not getting any data yet. Interesting. So I wonder if it hasn't finished processing yet. Could just be ahead of the curve here. Let me check on it. Oh yeah. I forgot. Now that I have a time, a time feature on here, I need to make sure that it's within the range of these timestamps, right? So, if I said like 15 hours ago, so what I really need to do is let's just, can I do absolute? And let's just say from the 23rd to the 25th. There we go. Now I'm starting to get data. Okay. And these are the positive tweets. Positive. And where's the other one? Does this one say positive? Positive. And positive. And I can also search for like a word like satisfying. So I could do like satisfying. Right? Very satisfying. Or how about package? Or I don't know what else is in here, but let me look through some more positive ones. What do we got in here? Happy, website, jewelry, books, jewelry, satisfying, books. So let's see how many people are mentioning books here. Books. There you go. So this gives you everybody talking about books. Glad I bought my books from FudgeMart. FudgeMart has a lot of books available for purchase. Just got books from FudgeMart. That's kind of cool, right? To be able to search through your data like that, with very little friction. Maybe you want to see all the tweets by a person, right? You can queue in on a person like J Time, right? So I could say user J Time. And then take a peek that way. Okay, here's one tweet from that user. The other cool thing is this happens in real time. So if I go back to the script, which is done running, and then let's have it throw out maybe 100 more tweets like that, and I run this, and now it's posting tweets to Elasticsearch. Maybe. Still grinding away. Hopefully it'll start posting tweets to Elasticsearch. There we go. And, this one here is from, this says digital downloads. See that? Digital downloads on FudgeMart. And this one says support is so bad, frustrated. So let's go look for these things. Let's go look for these things. Let's do downloads. There are new digital downloads on FudgeMart. Let's do support so bad, right? Support bad. Was it bad? Why is your support so bad? Frustrated, right? So it did find these other tweets that happened later. Right? Let's go back and look and see which one we just pushed out here. This one here says, why is your support so bad? Frustrated. Oh, here's, FudgeMart has a lot of books available for purchase. So let's look for available for purchase. Let's look for that. Obviously, these texts are like random. FudgeMart has a lot of books available for purchase. So see, it peels these babies right off relatively quickly. And it gives us all sorts of, like I can do this, looking for available for purchase like this. And then maybe from that, I can then look for a sentiment or, a user, and user is Bitall. Right? So I can combine these together to do search. And this is a lot like the kinds of searches that you would do like in, Google, right? I can just search for neutral, or let's search for positive without sentiment, right? So I get some of these sentiments are positive, but if the word positive appeared in the text, I would see that. A great way to test this is with the hashtag. So like there's a hashtag that says encouraging here, right? And it's also in the text. So watch this. I'm just going to search for encouraging. And you'll see that it finds the hashtag encouraging, and then it also just finds in the text encouraging. So it's very flexible and incredibly useful and super easy and fast. And like I said, imagine you had, a year's worth of logs that you were sifting through to try to figure out some problem. This would be a really easy and convenient and fast way to perform that kind of search. Let's take a look at the different types of Kibana visualizations that are out there. So, we saw Discover already. Discover is what we use when we want to just get some ad hoc insights from our Kibana data. And then what we'll do is we'll go over and do 3 demos. We'll do a demo of dashboard, do a demo of dashboard, we'll do a demo of canvas, and we'll do a demo of maps. And unfortunately, we won't do any ML in Kibana because that is for licensed users, and we are not a licensed user, and we won't take advantage of that. Now, that doesn't mean you can't do ML. It just means you can't do the ML plugins that are in Kibana. You'll have to, write your own in Python and add it as part of a pipeline. So you can still use Elasticsearch for a lot of things. You just can't use all the juicy integrations that they have built in unless you pay for it. All right. We're going to do a tour of the visualizations. We'll take a look at dashboards and the canvas and the map. And what we'll do is we'll install the demo data for flights, and then I'll show you how each of these works. And then after we do the tour visualizations, we'll spend some time building each of these visualizations. All right, I'm back out here at the Elastic homepage for Kibana, and down here it says try sample data. And let's install the flight data. Right, it's in there. Now what just happened here? Let's go to Discover, and you'll see that I have a new index pattern, Kibana sample data flights. And let's go take a look at the dashboard. It should have installed a dashboard for us. It has flights, global flight dashboard. So you can see a dashboard's kind of a cool thing because you have lots of different data points in your dashboard. Let me zoom it out and get my head out of the way. One more, now maybe 2 more, and then get my head out of the way. There we go. And you'll see that you've got different flight counts, and then the total number of flights, and all of the different origin cities, and then which ones were canceled, which ones weren't. And this allows me to sort of select different criteria, and then it will change my dashboard accordingly. And my dashboard has a couple of maps in here as well. Tells you where the flights are going. Here's flights that go into go into Ottawa. There's flights that go into, it's hard to do. Let me see if can I zoom it in. Zoom it in. There's the ones that go into Puerto Rico, Durham, Syracuse. Okay, so let's try something out here. Let's select a city. Let's select Syracuse. Should be in there, right? Syracuse. Guess not. Let's try New York. New York. Destination city. All right, that's not in there. So we could do New York and then apply the changes, and you'll see the data will change. So there's 6 flights that origin out of New York. And you can see the data on those flights and where they go. And you can see on this map where, let's see what we got here. It's a bubble of origin location. And you can see, half of those delays are weather, half are other delays. And here's a tag cloud. And then here's the actual data logs from each of those flights. So that's very cool. You can present a lot of data. You can provide some interactivity here, which is kind of slick. Let's do one where we take out New York now. And let's just find one with a very low ticket price. So the ticket price is between $165 and $200. Let's apply those changes. So there's 2 flights. These are the 2 flights. Let's maybe jack that up a bit. All right, now there's 6 flights, and these are all the destinations. So that's pretty neat. Very interesting to be able to build something like that. Let's take a look at what a canvas looks like. So I'm going to go show you what a canvas looks like. So a canvas is designed to present on a screen and be pixel perfect. So it's for maybe showing on a monitor or something like that. So this is what the canvas would look like. Boom, right like that. That would show up on a TV set. And this data that you see would change as the new data came in. The data that you see on the canvas would update. So each of these little elements here are updatable based on the source of the data. And that's basically the idea behind a canvas. So again, with that canvas, you can put that up on a TV screen. And you could build a flight board, departures, arrivals. You could build all sorts of things like that. You could build a leaderboard or a dashboard or anything like that with that tool. Look over each of these values, right, in the canvas. You see where the data comes from and how it gets there and things like that. That's kind of cool. Okay, so that's basically a canvas. And then likewise, we can look at a map. And we saw a couple maps already. You can build these maps. And you can take data and show it on the map. You can actually have that be time-sensitive data. And it'll last 15 minutes. Maybe we want to do this week, right? And then I can search for different criteria of the map, like maybe carrier. I don't know what's in there, so let's go with Cabana Airlines. Refresh. And so these are the ones with that are Cabana Airlines carriers. So it's really kind of cool. You can interact with the map. You can overlay search on top of the map. A lot of great options that you can take advantage of in Elasticsearch. So those are the 3 main elements that are available to us as part of the Cabana visualizations. There is, besides just search, right? There's dashboard, canvas, and map. Another cool thing about map is you can hit this button to show you how things change over time. Like maybe I want to go from here to here and then play, and then I can see sort of how the data changes over time. If I get this right, go. So we get to play it. It's kind of neat and see how the data changes. It's kind of cool. All right. So that is the map. Let's do a demo of creating a dashboard. What we're going to do is we're going to do some tweets in Jupyter, which we already have the tweets set up. And what we'll do is show those tweets in a table, give a pie chart of sentiment, and then allow us to select a user as the filter. That's basically the dashboard that we're going to want to create in this example. Well, I'll show you how to do that. Okay, I'm back out here in Kibana. Let's make our dashboard. So I'm going to go here to dashboard. And then this is a new dashboard that I have, right? If I go to create dashboard, I end up here. And what I'm going to do first is hit this create visualization button. And now I get to pick my filter, and I'll pick tweets. Let's do this. Let's put the user in here. And you'll see it already builds that bar chart. But what I want is a table. So I'm going to pick a table out of here. So there's my users. And what else do I want to add here? I want to add, let's add the user, and let's add the text that they tweeted. And maybe the sentiment. Where's the sentiment in here? Add that sentiment. Move these around a bit. All right. Looks pretty good. Move that sentiment over like that. So now I have, and I don't like this top values of user keyword. So there's probably a way to display this. I'm just going to call this user. Here we go. And then this one I'm just going to call sentiment. And then this one we'll call tweet. And that's good. And then this counter records, we'll leave that in there for now. I'm going to just hide it. All right, there's my table. Now what I'd like to do maybe is add a filter. So let me save this. And now that ends up on my dashboard. Right? And now what I want to do is maybe add a filter. So let's add a filter here. Roles. And let's make an options list. And then that index pattern is going to be tweets. And then let's filter this on the user. And let's make it multi-select. Why not? And that's good. And let's call this select user. Okay. That looks good. Save and return. Okay, now let's organize things a little better. Let's put this maybe above that, like this. This is what I'm not good at, is just making things look nice and juicy. All right, that looks good. And let's give it a shot now. So if I go in here and pick B and arrow, and then I hit apply changes, my data changes. So my data reflects the selections that I make up here. Now let's add some charts. Let's add a couple of charts here. Let me move this over. Let's add a visualization. Let's add a pie chart. Let's add a pie chart. much as I hate pie charts. Pies are for Thanksgiving, but whatever. And let's do this. Let's put in a size by sentiment keyword. And then, or maybe we want to slice by sentiment keyword. Sentiment keyword. And then we want the size to be just a count of the tweets. So we can just do that by ID. Here we go. And so that gives us a sentiment. And then I can maybe, that looks good. I like that. Save that and return. There you go. Put a title on it. Sentiment. Maybe move this over. And there's bow and arrow's sentiment. And I'll take that out. And then al fresco. And there's al fresco's sentiment. And I'll take that out. And let's put in Lisa Carferless. And let's see that person's sentiment. There you go. So that's kind of cool. That's basically a simple interactive dashboard, and how you do that in Kibana. Pretty easy to do. And what's really kind of nice about that is you still have this search up here. And up here, you could just search for like service. And it will search the filters for that. So, you know, if I'm looking, all these say service, and then I can look and say, oh, well, people are pretty positive about the service. They're positive or neutral. They're not negative. That's good. Or then maybe I can put in books and see that mostly positive about books, a little bit of negative on books, but not too bad. That's good. So that's basically how the dashboard works. Then when you're done, you can save the dashboard. I'm going to call this, you know, tweets, FudgeMart tweets. And you can put some tags on it, stuff like that. And then what you'll get when you go back to dashboards, you'll see that it's in there. It's kind of cool. So that's dashboards. Alrighty, let's move on to the next demo. That is me creating a map. So in this one, I'll just use the same tweets again. I will put the tweets on a map. And then before I can do that, I will need to add to the Kibana index pattern something that gives me geocoordinates that I can use on the map, because otherwise the map won't work. And then I'll add some really cool widgets to the map to adjust the time-oriented data. And you'll see tweets over time on the map. Pretty cool. All right, back out here in Kibana dashboard, and let's go add that index pattern. So I'm going to go down here to stack management, index patterns, tweets, add field, and this field is going to be a geopoint, and I'm just going to call it, I don't know, chords. I'm going to set the value here of chords to be emit doc lat value on value. Just emit those two values as an ordered pair so that now they show up as coordinates. And you see that? They show up as coordinates. I know it's hard to see. Right there. Show up as an ordered pair of coordinates. This is the format that it needs to be in for Kibana dashboards to understand how to use it. So this is perfect. So I'm just going to save that. Now I've got some coordinates saved. Now I can go back to maybe a map. And let's create a map. All right. And I'm going to zoom in on US because I think that's where most of my tweets are anyway. And I'm going to go in here, and roadmap's fine. And let's put some tweets on the map. So let's add a layer. And let's do some, see that we can do different things. We can do GeoJSON, choropleth, shaded areas across boundaries, heat map, geospatial data grouped in grids to show density. But let's try a heat map. I don't know how good it's going to be, but we can certainly try it instead of doing just plain old points and lines. Okay. There's lots of different things we can do. Let's try heat map. Okay, and let's check as an index pattern, tweets, and then there's your geospatial field already. And so a lot of tweets coming from Dallas. Let's figure out what happens when we break this up, right? So there you go. You got some from New York, some from Dallas, right? You got over here. There's some over here in the West Coast. I don't really know how many there are. It just doesn't really visually represent that. So I'll add that as a layer. That's great. And then how opaque do I want it to be, and how visible do I want it to be from a zoom level? Maybe I want to zoom 1 to 10. Maybe that'll control it a little better. Let's try that. Yeah, there we go. The zoom out, right? Big blob, and then you zoom in, and you get more isolated tweets. Whoops. More isolated tweets in there. All right. Maybe not a great layer. Let me try to add another layer. Let's try to do some points. Let's do some points. And let's once again go back to tweets and use chords and show as clusters. That looks good. All right, save that. All right, now we got some more interesting data, right? Because now you see there's 16 tweets down there in Texas, and there's 8 tweets over here and 20 in Cincinnati. Right, so that sort of helps you understand why those numbers are so high. And as you zoom around, there's a couple in Omaha. It's kind of neat. Now I can add more tweets if let's add some tweets at a faster rate of change. Let's say 1 to 2 seconds. Add another 200 tweets. Let's run that. Okay, now they're spilling out. Let's see how our map changes as we do this. Okay, let's zoom out. Let's see if it changes while we're going. Oh yeah, see it's changing? 18, 7, 11. That's what you get, baby. Some real time. Real time. Let me move that out of the way. Is there a way to expand this map out? I'm trying to expand it out here. Close that. There we go. Now I'm getting there. And you can see these numbers going up. With every tweet, these numbers are going up. That's kind of cool. That's kind of cool. That gives you that real-time feel on that map. So that's what you can do with maps. Now, I can also filter, because it's time series data, I can filter this if I want to only show how it changed over time, or also progress that map data over time. So there's lots of different little things I can do here with this map. I'm very curious as to where it picks these locations. I forgot how I did the algorithm for that. Anyway, that's maps for you. All right, it's time for the last demo here. In this demo, we'll use the canvas feature. And I'm not an expert at the canvas stuff because I'm just not artistic enough, but I will show you the functionality of the canvas. I will come up with cards that use not only Elasticsearch to get the card data, but also use Elasticsearch SQL to get the data, which is kind of a new feature in Elasticsearch. I'll demonstrate those to you now. All right, let's make that canvas. So I'm going to go up here, go to Canvas, create a work pad, and let's add something to my work pad. Maybe make that background color something cool like that. And let's call this workpad tweets. All right, and then let's do this. Let's just add up the number of tweets. So let's add an element, and let's add, let's see, what do we want to add? Let's add a, is that a hunk of text? I think it's a text, right? I guess we can add a gauge, maybe. I don't know. Let's add a text. See how this works. All right. I don't think I could mess with the data here, but we'll find out. I'm going to delete all this text out. Let's see what we got under data. It says this element's using demo data. I don't want that. Can I change that? Yeah, I think I'll use some Elasticsearch SQL here. And let's do select count star from tweets. $310 tweets. Save that. Now, I don't know if I can actually put that data in here anyway. I don't think this is the right the right container for this. I really don't. So let me try another container here. Yeah, that's definitely not the right one. Let me take that one out. Let's add, let's see, I think it's, oh, there it is, metric. So I'm going to add a metric. There we go. And let's add the number of tweets. So I'm going to change this to say tweets. And this is going to be a number. And then I'm going to go to data. And it's using demo data. So I need to switch this to, let's use Elasticsearch SQL. Select star from tweets. And let's get a count of that. Like that. Preview that data. 325 tweets. Still tweeting, by the way. Save. Save that. Go back to display. Now I got to pick the right value here. All right. Number, tweets. Let's play the count. Let me go back here and let's as tweet count. Let's make our lives a little easier. Tweet count number. That should be good. And an unknown variable country. Let's see what I'm doing wrong here. Preview that data again. Tweet count. There it is. Oh, it says tweet count hash. I don't know if that matters. Certainly doesn't display that here. Just says that's it. Just says tweet count. Let me see what else I got here. Maybe because I can count here, maybe I shouldn't be counting here. Let's just do select star from tweets like this. See if that makes a difference. All right, save that. And let's count the ID. There we go. Now we're getting somewhere. So there's 325 tweets. Let's go back here and let's run it again. Okay, more tweets are coming in. Let's see what happens here. See if it starts to refresh. $338 tweets. Okay, it is refreshing. Okay. Let's add something else here. Let's add another element. Let's add like some kind of, maybe we'll add another pie chart. And let's do the sentiment, right? And we can take this pie chart like this, zoom it out, and let's go back to data. And this time we won't use SQL. We will use just the Elasticsearch documents, and we will use tweets here like this. And we will use let's do sentiment. Yep, that looks good. And then let's go here. And the slice label is going to be count. And this is going to be value. We're going to have those backwards. Count, value. Okay, now that didn't come out the way I wanted, so let me go back here. And then maybe add another column. ID. There we go. All right, and then maybe I can save that. And go back to display. And if I could only figure out how to do this, it would be amazing. I'm just so bad at these kinds of things. There, that went away. Oh, and there we have it. All right, so there you go. Now, if I could just style it so it doesn't look horrible. That didn't do what I wanted. Where'd my thing go? Now it's gone. Gotta pick a color palette. Element style. It just disappeared on me. That's weird. There we go. It wasn't my fault. There's like a weird bug going on here. I don't know if it's a browser bug or whatever, but it was the first time you pick one of these color palettes, it just completely borked it on you, and you didn't get to see it. So that was not my bad. So I'll end this dumpster fire before it gets any worse. But see, you could totally make a really nice story, visual story, with your data like this. I still don't think my tweets are right because boy, they shouldn't be even like that. So maybe this should be a count of sentiment keyword. There we go. Now we're getting somewhere. That looks a lot better. Okay. What drives me nuts is I could do this in Pandas in like 3 clicks, but I got to sit here and drag around and guess what these little boxes and buttons mean. But welcome to the world of business intelligence. This is sort of how BI works. You know, you can refresh this and see new data. Okay. All right, and that is a canvas. Pixel perfect drawing. And you can make multiple pages in your canvas if you want. You can have additional pages and have it rotate through like a slideshow if you want of different slides. So it's pretty cool. A lot of options here for the canvas. All right, we're back here and we're drilling Elasticsearch now. Now, Elasticsearch does support drill. It's kind of in beta right now, but you know that could change. Probably will change a lot in the future. Basically, your drill is going to treat your indexes as tables and your documents as table rows. And anytime it tries to query out an attribute that's not there, you'll just get null. Just like Hadoop does with schema on read. And this allows us that if we're familiar with SQL, we can query that index search data with SQL as opposed to using Lucene or Kibana KQL. I strongly encourage you to embrace Kibana KQL / Lucene. It'd actually be better to embrace Lucene because you'll get more mileage out of it. And it's a pretty industry standard across across all search, being able to use Lucene queries and knowing how to do them is going to be useful. So yeah, you configure Elastic in drill, and then you can then say select star from, elastic.people, and then you're cooking. Or you can then just get elastic.tweets. Now there is one issue in the version of drill we have right now, version 1.19, where it takes a while to read an index. This will be fixed if and when a future version of drill ever gets released. There's already a patch for it, but the newer version of drill has not been released yet. So what happens is if you configure this in drill and then run it, it takes 5 minutes before it shows you the data, and it has to do with the fact that it can't figure out the indexes in Elastic for some reason. Drill can't do that, and it's a bug. Let's talk about Spark and Elastic. So there's a connector for Elastic. It allows us to write data frames to an Elasticsearch index. We can load an entire index into a Spark data frame. It does not support Lucene or Kibana queries. It does not handle any pass-through whatsoever. It does not handle any kinds of nested schemas without a custom mapping in Elasticsearch. So if you have nested mapping types or nested list types, those will not come in easily into Elasticsearch. So there are some limitations, okay? Unless you're going to be in the business of making a mapping beforehand, which is probably not a bad idea if you're going to really heavy duty be into Elasticsearch. Okay. So let's just do a final quick demo of how to get something in and out of Elastic with Spark. Okay, here I am out in Spark, and I'm loading in my favorite data set, FudgeMart order details. And I will use ES, which is the storage format, to save to a index called FM order details with the default doc. I am going to overwrite those values in Elasticsearch. This takes a bit. Even though it says it's done, you got to wait a bit, because it takes a while for Elasticsearch to sort of catch up and build those indexes. And then once it does, you should be able to read this back out like you would read anything back out from Elastic. The key here is if there's any nested data at all in here, I can't do it this way. I first need to send it that mapping that explains how all of these columns should be interpreted and what their data types are. And then after I send it that mapping, then I can send it the index, and then it should handle the nested data. But without sending it that custom mapping, it won't work. So as long as your data is pretty flat and tabularized, it won't be an issue. Most of the data that you are sending to Elastic is pretty flat and tabularized. It's just one row and then an atomic value in each row. Pretty flat and simple. That's basically it for reading and writing Elastic from Spark. Now, what it does not do is if I put some kind of where on here, it will not pass that to Elastic. I'm pretty sure that is the case. I guess we could check that. This might be a good lesson, right? Let's see, just to check. So if I say where, if I have FM2 now here, and I do FM2 where, what's a field in here that we have? This one here, customer city. All right, if I do customer city equals Fresno, does that query happen in Spark or Elastic? Let's find out. So I got a filter, but that filter happens after it scans Elastic. And it doesn't look like, oh, it does push the filter. I'll be dipped. See that? It does push the filter down. So that's great. So it does pass these down to Elastic, which means you are not pulling everything out of Elastic into Spark. That's wonderful. Now I want to try something else because this is really kind of cool to know that that's the case, right? So I'm going to actually put a note on that. Filters are pushed down into Elastic. Let's try something else. Let's try something more complicated that I don't know how to write in Lucene, like this number here, right? Order total. So order total, let's do that. And order total is less than 500. I can't do that in Lucene easily, but I know how to write it in Spark. The question is will it pass both of these through, because everything's indexed. So you hope it should. And let's see here, push filters. Customer is not null. Order total is not null. Equal to City Fresno, less than order. So it does push the filters down. That is awesome and great to know. And expected. I don't know why I thought it wouldn't do that. It definitely did do that. And just out of curiosity, I wonder what this data looks like. Let me do one last. And let's do 2 pandas and see what this baby looks like. Oh, there's a couple rows in there. There's a couple rows in there. That's neat. Okay, that is Spark and Elastic. All right, let's sum up. Long unit. Elasticsearch uses inverted index to allow us to search over all of the data. So all the data that gets put into Elastic gets structured for generic keyword searches, but also searches by fields if it can detect the fields. It scales horizontally and is eventually consistent. So it uses a sharding and replication model, and the replications happen on the back channel. You can always read out, but you're not guaranteed to read out exactly what you put in at the time you put it in. Search databases have very specific use cases and are not appropriate for generic OLTP/CRUD systems. You're not going to build some mobile app in here that takes orders and things like that. It's not the right use case for the job, although you may use that type of, you may have that app and then use the search to search through your orders and search for products in the product catalog. That would be very appropriate, but it's not appropriate for just, writing the entire database in just Elastic. Kibana is like the front end to Elastic. We use it to query Elastic easily, so we don't have to use the API. It also has dashboarding capabilities, doing maps, and you also saw me fumble around with canvases. And you can use that Spark connector from Elasticsearch to read entire indexes and write to indexes, and you can also pass the filters through. Pretty cool.